Hi, welcome back. So now let us continue with project scheduling, but this time around our scheduling is with uncertain activity times. Okay, uncertain activity times. So at the end, you should be able to come up with the project network just like this. And if you still remember, you need to come up with all these earliest start time, earliest finish time, latest start time and latest finish time, and this one is by using forward and this one is backward. Yeah, but you need to determine the durations to be filled in into this part first. Okay, because this is the uncertain activity times that we're dealing with. Now let's go to the example. Okay, the HS Doherty company has manufactured industrial vacuum cleaning system for many years. So recently, a member of the company's new product research team submitted a report suggesting that the company consider manufacturing a cordless vacuum cleaner. So now they want to come up with the cordless. The new product, referred to as PERT, could contribute to Doherty expansion into the household market. Management hopes that it can be manufactured at a reasonable cost and that its portability and no-cord convenience will make it extremely attractive. Doherty management wants to study the feasibility of manufacturing PERT product. The feasible study will recommend the action to be taken. To complete this study, information must be obtained from the firm research and development, product testing, manufacturing, cost estimating, and market research groups. How long? Okay, the question is, how long will this feasibility study take? In the following discussion, we show how to answer this question and provide an activity schedule for the project. So continue with this one. So this is the activity list for the this is the activity list. This is the activity list for the PERT project, in which you have the activities, the description, and also the immediate predecessor. So here we have how many activities? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All 10. Okay. Then, with uncertain activity times, it is best described by range of possible values because it is uncertain. So normally the project will give you like what is the optimistic time. So optimistic time is the minimum activity if everything progress ideally. So normally this is the least time, yeah? The optimistic time. The most probable time is the most probable activity time under normal conditions. Okay. Then you also have pessimistic time. Okay, the maximum activity time if significant delays are encountered. Okay, so A is you will have a formula here in which A is representing optimistic time, M represent most probable time, and B represent pessimistic time. Okay, so for this PERT cordless vacuum cleaner project, okay, in the table here you can find this optimistic, most probable, and pessimistic time. Yeah. So if you look at here, you have all these four values. You have all these three values for each activities. Okay, so this is your A, this is your M, and this is your B. All right. Now, for every activities, you need to be able to compute the average or the expected time. You need to be able to compute the average and expected time, in which the formula is A plus 4M plus B divided by C. So this is the time. This is the average time. And you also need to compute variance of the activity times. Okay, so the variance, the formula is just like this one. Okay, right. Okay, remember that in the previous table, we only have activities and we have all these 3 times given. Okay, now we need to find the average. Sorry, we need to find the average. Average and also the variance. Okay, so you need to have another two new column need to be added here, which will go to expected time and also the variance. So how to get this expected time? If you still remember, you need to use this formula. Okay, sorry, you need to use this formula here. You need to use this formula here. 4 plus A plus 4M plus B. So T here is A plus 4M plus B divided by C. So you will have, for this one, how you will get it is by having A is 4 plus M is 5. So you have 4 times 5 plus B. B is 6. B is 12. And then you need to divide by 6. With this, you will get 6 in here. Okay, you'll get back this 6. Okay, then you need to calculate all the expected time for every activities here. Okay, I hoped that you can do this on your own. Alright, then for variance, okay, variance, you need to use this one here, B minus A divided by 6 to the power of 2. So it's going to be B minus A. So I'm going to put it here. B minus A divided by 6 to the power of 2 for the variance. So in order for you to get this number, okay, what you have to do is, our B here is 12 minus A. A is 4 divided by 6 to the power of 2. Then only you can get 1.78. And you need to follow this formula for every activity. Okay. Now, once you have done that, then only you can come up with the diagram for the project network, just like what we done before. So with earlier start time and finish time. Okay, and if you can still remember, I hope that you'll do this. Okay, you need to do this following the previous videos, which I show you how to compute the earlier start time and the finish time. But the things that you need to take note here is that the durations is the expected time that we have calculated previously using, if you still remember, the T is equal to A plus 4M plus B divided by 6. Okay, right. You need to do this on your own. Okay, you need to do this on your own for the earliest start time and finish time. Okay, you can always refer to the value here. Okay, these are, you can check whether you have the same one or not. Okay, then you need to complete with latest start time and finish time. Okay, in which you need to be able to get just like this one. Okay, I hope you do this on your own. Please do this. Okay, therefore with this, then only you can exercise, you can practice. Okay, then you must carry on with how to get the critical path, okay? If you still remember, the critical path is by having the slack, okay? And slack that shows 0 is all the critical path. So the critical path for here is, for this project, is A, E, H, I, and G. Right. Then, okay, one of the famous questions that will be asked will be something like, what is the expected completion time? Okay, so the expected completion time will be 17 weeks. Okay, how you get this is actually by having the durations. You add up the durations for all the critical path, A, E, H, I, J. So that is how you want to get the expected completion time, okay, in which you will have 17 for this example, which you need to try on, okay. Then the variance in the project completion time is the sum of the variance of the critical path activities, and you also need to try this and see whether you get the variance as 2.72 or not. Okay, good luck.